4.09, special right triangles 2. All right, so what is it? What is it? It's just special right triangles and more. So you're just going to be given a little bit more to think about in regards to the special right triangles and what they mean. So here's an example problem. Triangle LMN is a right triangle with right angle N and tangent of L is 1. Now you're being asked, is triangle LMN equilateral, isosceles, or scaling? And you're like, I don't know. I'm not going to find that out. All right, well, so sketch yourself a right triangle because they did not give you one to begin with. We know that the N has to go in the right angle, so the other two angles can go wherever we like. We'll put the L up top and the N at the bottom. Now we also know that the tangent of L is equal to 1. Well, what is tangent? Tangent is opposite over adjacent. We don't know these values, but we do know that no matter what they are, whatever side length is across from L and adjacent to L, when I divide them, I get 1. So what does that mean? That the opposite and the adjacent are both the same value. I can represent those with any value I'd like. Let's say x, because x divided by x is just 1. So now that we've established that those two legs are congruent, even though my diagram doesn't look that way, it doesn't matter. Which one of these three does that fall under? Well, that is an isosceles. It cannot be equilateral as a right triangle. There's a big hint there, right? All three sides can't be congruent as a right triangle. If you have a 90-degree angle, one side has to be longer than the other two. All right, additionally, you could be asked to find the area of a regular polygon. Simply put, here is the formula. The area of a regular polygon is 1/2 times the lowercase a stands for a fun word, apothem. Some people might say apothem. I think it's apothem. So apothem is just the height, essentially, from the center of the regular polygon that meets at a 90-degree angle at the center of one of the sides. Okay, that is the apothem, the perpendicular bisector of a side, and that goes through the center there. All right, so the apothem times the capital P is a capital letter because it means you got more to do to get that. The capital P stands for perimeter. So let's pretend that this lowercase a, our apothem, was equal to 2. And then let's say that the B represents the side length of this regular octagon, and let's say that it's 1. So if I wanted to plug this in, the area for this regular polygon would be 1/2 times the apothem, which is 2, times the perimeter of this regular octagon, which is 8, right? Each side is 1 times 8 sides, 8. So then once we do that math, we'll see that the area of this regular polygon is 8 units squared.